Today we're going to be talking about the second way that you solve systems of equations. And if you remember from lesson 6.1, when we were talking about solving equations or systems of equations by graphing, I told you that the main part of learning to solve them by graphing is really being able to look at a lot of different information on a graph, and then also to kind of get the feel for what you're going to be solving for when you use substitution and elimination, which is our next two lessons. This is typically what you're going to use, is either substitution or elimination. You don't want to use graphing on a regular basis unless, of course, you're using it for the reasons we talked about when we learned graphing. So write this down, hit play when you're ready to walk through the example, then we'll walk through the example and add some more stuff to the left after that. When you're looking for how you're going to solve these systems, one of the main things that you want to look for, and you'll see more tomorrow when we talk about elimination, but one of the main things that you want to look for is an isolated variable, which in this case we have an isolated variable here and here. Doesn't matter which variable is isolated. It can be x or y or whatever letter they give you, even though these are in slope-intercept form, which a lot of times they will be, but it doesn't have to be. You're just looking for one of the variables that's already alone, or a variable that would be very easy to get alone. Like that would be really easy to move and then move whatever this is, something like that. So you can kind of look around for a variable that has a coefficient of 1 or is already alone, and that's your goal. Now, once you have that, the way you have to think about this is, if I was to look, because this equation is easier to explain it to you using, since it's such a simple mathematical operation right here. If I was to say x was 2, you would tell me y is 9. So the goal here is to take one of these two equations, substitute it into the other equation so that you have one variable across the board. And I'll show you what that does in a few minutes here. But what I wanted you to look at is if we said this was 2, x was 2, we would know y was 9. We could put 9 in for y here, and we would have the same thing as this, if that makes sense right there. So my y here is equal to x plus 7, which means that since I'm looking for the one point where these two lines cross, I know that x is exactly the same value and y is exactly the same value in each of these. So whatever this x ends up being, if I add 7 to it, I have y here also. That's substitution. So here's how you're going to work substitution out when you go to solve for these. You look for your isolated variable, which in this case we actually have two isolated variables, so you could do either or. I'm going to use the bottom equation just so we can write a little bit and you can see. Once you find your isolated variable, this is where it gets easy to confuse it. Your isolated variable is what you're going to plug everything over here in for on the other equation. So the way that I want you to learn how to do it is find your isolated variable, circle the other side, or a highlighter if you want to highlight it. That is equal to y. Because that's equal to y, I can plug it in for y in my other equation. So then you draw an arrow to the variable that was isolated in the other equation. And now you're going to rewrite it as one equation. And notice when you rewrite it as one equation, you're going to have x plus 7 for y, and you're going to have negative 4x plus 8 over here. You're going to end up with one variable. Now you're going to be able to solve for that one variable. When you have two variables, you can't solve unless you know what one of the values is. So that's the whole purpose in this. Okay, if you don't understand what I just went through, hit rewind, start over with what I just explained here again, because that's really important that you understood what I just did there. Common mistake is kids want to plug this in here or here, and then they get confused because then they still have two variables and they're not sure what to do. So just make sure this is my isolated variable. That is equal to it. I'm plugging it in for the isolated variable in the other equation. And then once I rewrite it, it looks like this. So instead of a y, I have x plus 7. And then I'm going to write the rest in green on that one just so you kind of see where I got that x plus 7. Equals negative 4x plus 8. there's my y, and there's the other side of the equation, equals negative 4x plus 8. Now you just solve for x. You have to be really careful when you're plugging these in to make sure there's nothing you're going to have to distribute to it, because if there is, you're going to need parentheses around that. In this case, we didn't. So now we're going to solve. Isolate your x's. Okay, I'm just going to put solve here for x. Some of you might want to hit pause and just do it on your own and then hit play and check it for practice. Others, you can just follow along as we go here. So I'm going to isolate x. I've got this imaginary line here that some of you might still want to use if you're not totally confident with these yet. I need to move x's to the same side. I notice I have a negative here. If I move it across, it becomes positive. So positive 4x there. Now you add this. Remember, that's a coefficient of 1. So you have 5x plus 7 equals 8. And we're still solving for x here. So I'm going to subtract 7 from both sides. I end up with 5x equals 1. And I divide both sides by 5. And x equals 1/5. Now that I have x, I can go find y, because remember, we're looking for that one point where x and y are the exact same value in each of these equations. So now I know 1/5 could go in for x here, or 1/5 could go in for x there. Either one works, because I'm still going to get the same value for y. I'm going to go ahead and look at the easier of the two equations. This one looks easier. So I'm going to plug in 1/5 here, solve for y, get the same answer as the person who would have plugged in 1/5 there, as long as you're doing all of your operations correctly. So let's go ahead and write that down. Go ahead and copy that down. It's just saying what I talked to you about. You found x. Now that you have x, you get to plug x in for for either equation to find y. And remember, I said I was going to use this equation because it was easier. So when we go to plug that in, we end up with y equals 1/5 plus 7. And in this case, we don't have to do a fraction buster, because you all know that 1/5 plus 7 is 7 and 1/5. Or you could also write this as an improper fraction. Remember, improper fractions, 7 times 5 is 35. 35 plus 1 is 36 over your denominator, which is 5. So either of those answers would be acceptable. Now, here's the key to writing your answers to these. When we aren't talking about a word problem, you're always going to write your answer to these as an ordered pair, as a point on a coordinate plane. So you're always going to write in your x value first, your y value second, just like you were writing an ordered pair. Even if you found y first, you still need to write it in the correct order there. So your solution is going to be written as x comma y. Once we get to word problems, you won't always do that. You'll write them in words. Our solution here is 1/5 and 36/5. These take a lot of time. They take a lot of room. I want you to be clear, in this case, it's not going to be as easy to check because these are fractions, and I know a lot of you tend to make mistakes when you evaluate with fractions. But just so that you're all clear here, if I was to go plug in 1/5 and 36/5, I'm going to move this up here for x and y and simplify it down, it would be a balanced equation. So whatever my y was is going to equal the other side of the equation also. And if I plugged it in here, it would do the same thing. It has to be true for both to be the correct answer. I'm going to show you an example of checking it on an easier one later, but I want you to understand that. It's really important to understand that. And copy this down into the left side of your notes. I know it's a lot to copy down, but it kind of goes through the whole process, so you can look at that process again later when you're practicing these. You're looking for an isolated variable. You're going to circle that and then plug it into the other equation. Okay, plug the other side into the other equation, which is what we talked about at the beginning. So you're substituting it in. You should have one equation with one variable at that point, like we did right here. If you don't, you know you made a mistake. So I want you to highlight that because that is the key. If you don't have one equation with one variable after you substitute, you did not do it correctly. That's where your mistake could be made right there. Once you have that, you solve for the variable that you've got left. Then you use your solution for that variable to find the other. And then your solution is an ordered pair. Hit pause, hit play when you're done copying. Here's another example that I want you just to copy down, and we're going to go through it again just so you get the feel for how this works. And it's also looking at plugging this in. Here's your isolated variable. You're going to be plugging it in to something you're going to have to distribute to. So once you have that copied down, let's go ahead and walk through it. Notice this is your isolated variable. Once you see your isolated variable, you're going to circle the other side. All of that needs to be plugged in for that variable in your other equation, which we're going to have something to distribute, but it's not that big of a deal in this case because we don't have a number. Now you're going to rewrite the equation as one equation, 7x subtracting 2x equals 15. So instead of y, I plugged in 2x. I want you to get the habit of putting parentheses around it whenever you are distributing to something or plugging in for something that's on a side that's not alone. If this had been two terms, you would need to distribute that negative. Since it isn't two terms, you're going to get to just distribute it once anyway, but again, it's important for you to get used to it now. If it had been plugged in here, we would have needed to distribute 7 to it. And you'll get a lot of practice at these, so you'll see what I'm talking about. We don't have anything we have to worry about distributing, so we can go ahead and rewrite the equation and solve for x. So we have 7x subtracting 2x equals 15. This is on the same side, so we're just going to combine it. And we have 5x equals 15. Solve for x, so we're dividing both sides by 5, and x equals 3. Now that you have x, you can plug 3 in for x here, or you can plug 3 in for x here. And again, take a look at those. Which one makes more sense to plug 3 into? Hopefully most of you notice this is going to be really easy to find your value of y based on x being 3. This one, a little more work to do. But if you were going to plug it into this one, we'll walk through it after just to make sure, you should still end up with the same solution. So now we're going to say if x equals 3, then solve for y. And we have y equals 2x as our equation that we're going to use. I plug in 3 and I evaluate, and I get y equals 2 times 3, y equals 6. So my solution is x is 3, y is 6. And remember, you're not always going to find x first, so always put those in the correct order. Now I want to talk to you about how you can check your solutions to these to make sure you got them right. I'm going to show you with a basic example, and you can do this anytime with any of them. What you do is you have your x and your y. You have your two equations. Y equals 2x was my first equation. I plug in and evaluate with x and y. So 6 equals 2 times 3. 6 equals 6, and it's true for that equation, just like we did in lesson 6.1 when we were checking to see if a solution was true. Now you have to make sure it's true for the other equation. The other equation was 7x subtracting y equals 15. So 7 times 3 subtracting 6 equals 15. 21 subtracting 6 equals 15. And 15 equals 15. It was true for both. Once you know that that solution is true for both, you know you did all of your math correctly. So that's how you check these. When you have a fraction in your solution, it's not going to be as easy to check because I know it's easier to make mistakes when you're evaluating, but at least now you know how you can check these. Copy these 3 practices down, and once you're done, all we're going to do with these is practice just finding the variable that we should substitute for in the other equation, drawing our circle and moving it over and rewriting it as the one equation under it, just so we practice that idea. If you want to go ahead and try these on your own and then check them, you can. Otherwise, just if you're still getting the feel for it, just follow along with me. So here's our 2 given equations, and what you're looking for is an isolated variable. This equation has an isolated y. It has an x that would be easy to isolate if we needed to because it's a coefficient of 1, but we already have y alone. No variable alone here. This is your best bet, so this is your isolated variable. You circle this, draw your line to that in the other equation. And then remember, you're going to rewrite it. Now this is a perfect example of using parentheses that I was talking about. So I'm just going to rewrite it right here, and it's 2 parentheses. Instead of a y, I'm going to put in 3 plus x, and then plus x equals 10. There's my one equation with one variable, the same variable. Don't forget here you would have to distribute 2 to each of them before you solved. Now we look at the next one. Again, I see an isolated variable here. It's already alone. So I know this is equal to x. This can be plugged in for x here. No other isolated variables, so that's my only option at this point. So I'm going to circle that, and it's going to get plugged in for the variable that was isolated, which is right there. And again, I have something that's going to need to multiply, so I need parentheses around it. And when I go to rewrite it, I have 2 parentheses, 4 plus 2y plus 3y equals 8y. One equation, one variable. And I'm not talking about only one of a variable, just the fact that there's all y's here. All right, go to the third one. Notice when we get to the third one, there's no isolated variable, no isolated variable. But if I had to isolate a variable, I want to look at each of them and I want to figure out which one is the easiest to isolate. Because this has a coefficient of 1, that's the easiest to isolate because I'm not going to have to divide everything by something to move the coefficient that's in front of it. So once you see that, this would be what you want to isolate. So you change that equation, which you all know how to do, move 4x over. You end up rewriting it, y equals negative 4x plus 10. Okay, that's your new equation here. Now this is my isolated variable. Circle this, plug it in for y in the other equation. And I'm not going to write that equation out because we're kind of out of room here, but if you want to, you can. It would be 3x plus 6 parentheses, negative 4x plus 10, end of parentheses, equals 8. I guess I can try to write it right here. So 3x plus 6 negative 4x plus 10 equals 8. And then from there I would have to distribute a positive 6 before I could start isolating my x's. Add this to the left side. It's what we just talked about here. You must have an isolated variable in order to even use substitution. And if there isn't an isolated variable, you're going to have to isolate one. You're always going to look for a coefficient of 1, like this y had, because it's your easiest. You're not always going to have a coefficient of 1. Sometimes you might just have to choose any other one that you want to. It won't matter. But you want to try to use a coefficient of 1 because it's less likely to give you a fraction to plug in. And I know all of you love evaluating with fractions. Write this down, and then we're going to walk through just another practice using the same exact thing we've already learned. Once you get this pattern down, you're going to use it every time. It's not going to change on you. You're going to notice in the book that they always give you the equations one under the other. When we're using substitution, it's up to you, but I suggest you leave a line between, or you just go ahead and start writing them side by side like that instead when you write them into your notebook. All right, so I'm going through my rules, and my rules are I need an isolated variable in order to substitute in. No isolated variable in this equation, no coefficient of 1. So I'm going to move to the next equation and see. I notice there's no isolated variable, but there is a coefficient of 1. So that is the variable that I want to isolate. So again, I suggest you use a highlighter. This is what you want to isolate. Now you're going to rewrite your second equation with your y isolated. You end up with y equals, you added 6x to both sides, 6x subtracting 7. If you didn't see what I just did there, go ahead and show the step, plus 6x plus 6x. Now I have y alone. If you want, you can just write this equation, bring it back down. It's up to you how you want to do that. So this equation just comes down. I have 3y plus 2x equals 4. Here's my two equations. This is my isolated variable. So I'm going to circle the other side, draw an arrow to the y in the other equation, which is right there. And then I'm going to rewrite it. I'm not going to use y. Instead, I'm going to use that. I have a binomial, 2 terms. Have to put parentheses around it because I'm going to have to distribute 3 to it. Hopefully you're getting really good at starting to notice those little teeny pieces of these terms like we talked about. So when I rewrite it, I have 3 parentheses and then a 6x subtracting 7 instead of a y plus 2x equals 4. And now we're actually going to practice distributing. You saw it in those few practices that we didn't solve. So remember, 3 gets distributed to each term. It's a positive 3. I don't have to worry about a negative there, but I do have a negative there. I end up with 18x subtracting 21 plus 2x equals 4. And now I'm going to solve for x. 18x and 2x are on the same side, so I just add them. Remember, you're only doing the opposite when you're moving across that line. So I end up with 20x subtracting 21 equals 4. Now I'm going to add 21 to both sides, and I end up with 20x equals 25. Divide both sides by 20. And I'm going to simplify it as I rewrite it. 5 goes into 25 5 times, and 5 goes into 20 4 times. So x is 5/4. Now that I have x, I can find y. I can plug it into this equation. I can plug it into this equation. It doesn't matter. You get to choose. What I do notice here when I'm looking through this is that 5/4 right here, it's going to simplify a little bit, but I'm still going to have a fraction to deal with. And then I look over here, simplify a little bit, but I'm still going to have a fraction to deal with. So I'm really not going to be better off with fractions in either equation. But this one doesn't have any negatives. This one has 2 negatives to worry about. So some of you just want to start looking for that. You can plug it into this one or this one. You'll all get the same answer. We're going to use this one right here. So now find y when x equals 5/4. Again, we're using this equation. That was an original equation. 3y plus 2x equals 4. So I have 3y plus 2/1 times 5/4 equals 4. And then I end up with 3y plus, hopefully most of you notice this will simplify to a 1 and a 2. 1 times 5 is 5, 1 times 2 is 2, so 5/2 equals 4. Okay, from this point you can do a fraction buster. I'm going to go ahead and do the fraction buster in red or in pink. Your fraction buster is 2 because there's only one fraction and your denominator is 2. You have 3 terms, so you're going to multiply by 2, multiply by 2, and multiply by 2. When you do that, you end up with 6y plus these cancel. A lot of you have been missing that. Those cancel as 2's become a 1. So you just have 5 left over equals 8. Remember, the whole goal of a fraction buster is in one step, you should have no more fractions there. Okay, if you still had a fraction here, you made a mistake. Fraction busters means you got rid of the fraction. Now I'm solving for y, so I'm going to subtract 5, and I end up with 6y equals 3. Divide both sides by 6. 3/6 can simplify to 1/2. And then your solution would be written as a point. So your solution is 5/4 for x, 1/2 for y. And if you were to take that, plug it into each of the original equations, it would balance them both out. Finish copying anything you need to there. Hit play when you're ready. Copy this down on the left. It's what I already talked to you about. You just need to be careful for distributing. When you're substituting, just like when you were learning to evaluate, you always use parentheses so that you make sure you distribute when needed. As you get better and better at this, you're going to see when you actually need your parentheses and when you don't. Like in that very first example, I didn't use parentheses because I was plugging something in alone on one side of the equation. There was nothing I was ever going to have to distribute to that. But if you're not good at it, you always want to use parentheses. Otherwise, you'll start to see when you really need them because of distributing and when you won't. Go ahead and copy this down, and then we'll go through it. All right, so we're following the same idea. You're going to be setting up 2 equations based on 2 sets of information. You're going to be using 2 variables. Easiest way to always get used to doing these is going to be to really, even if you've kind of fought me before on it, you really need to start identifying your variables first. What are you looking for? and you should have 2 of them every time. So my variables are what I'm going to look for first. And I'm going to go through here. There are 193 people, so maybe people who need transportation, maybe transportation. There are 8 drivers and 2 types of vehicles. Buses can seat 51 people, vans can seat 8. This is not talking about the drivers here. How many buses and vans are needed? There's my 2 variables. Okay, they're almost always going to be in your question. So I'm going to go ahead and say B is buses and V is vans. Now I've identified my 2 variables. I know that these are going to be used in my equations. Now I need to start looking for other important information. So I'm going to go ahead in blue and look for important information. Well, let's see, 193 people. Okay, I need to stop and think. If there's 193 people, then I know, and I have to think about it for a minute. Well, let's see. 8 drivers. Okay, so there's 8 drivers. 193 people is going to have to do with something. 8 drivers is going to have to do with something. So this is where you have to be able to identify your difference. I'm going to go ahead and underline this in orange. Hopefully it's enough color difference in your video. What I'm looking for here is I notice 193 people, and for those of you who went on the Universal Studios field trip, I basically had to use a system of equations to figure out how many buses I needed because of how many people I had driving. And so this is a system of equations that I used to plan the Universal Studios field trip that the video production and drama just went on. What I know is that I can take 51 people, and we're not even worried about the drivers because the drivers aren't included in this number. So we can take 51 people per every bus. And we can take 8 people per every van. That total needs to add up to 193 people. So 51 people and 8 people are important for how many per bus and how many per van. That's going to be my first equation. 51 for every bus plus 8 for every van equals 193 people. If you didn't understand that, go rewind it or go read it again and look at it. So a bus can seat 51 people. A van can seat 8. My total people are 193. The other equation is based on my drivers. Because I only have 8 drivers, that means that the total number of vehicles can only be 8 because I only have 8 people to drive them. This has nothing to do with how many people are on a bus or how many people are on a van. It just has to do with our number of buses and vans can only equal 8. So my buses plus my vans can equal 8 because I had 8 drivers. There's my 2 equations based on my 2 sets of information. Now I have to go through substitution to go ahead and solve and find out how many vans and buses I need. Notice this first equation is in standard form, no isolated variable, and there's coefficients in both of them. This is the equation that looks much easier to go ahead and isolate one of the variables. Completely up to you which one you want to isolate. Does not matter. You choose. I'm going to go ahead and isolate B just because it's the first one. And the way that I isolate B is I subtract B from both sides. Once I do that, I have B equals 8 subtracting V. Make sure that you keep that negative with the V there. My other original equation was the 51 plus, oops, I forgot my B, 51B plus 8V equals 193. There's my 2 equations. This one is the isolated variable, so I can substitute that in for B over there. If you want to go ahead and try it on your own from here, you can. If not, then just follow along with me. I have some really good news about this chapter. You are allowed to use calculators throughout this whole chapter on your homework. I want you to be using a calculator. I don't want you wasting a lot of time with these trying to do calculations. I want you practicing real-life application this chapter. It's a big real-life application chapter. So I want you practicing it the way that you would be in the real world, which is you have calculators. Use your calculator on all of your homework, and you're going to be able to use the calculator on the test for all the word problems that we do. Because I don't want you worrying about calculations with the word problems. It just takes too long. So we're going to go ahead and rewrite this as one equation with no b. We're getting rid of the b's. We're only going to have v. 51 parentheses 8 subtracting v plus 8v here equals 193. I need to distribute. When I distribute 51 times 8, I get 408. Subtracting 51v, don't forget you're distributing to both, plus 8v equals 193. These are like terms. 408 subtracting 43, v equals 193. So all I did was combine those, and remember I'm combining them on the same side, so I'm not doing opposite operations. Isolate my v. Notice you have a negative. Be careful with that, but that's okay. I'm going to go ahead and isolate it that way because I want you to see what happens so that you kind of catch mistakes sometimes if you happen to make them. Here you should have a negative integer, negative answer also. So I have negative 43v equals a negative 215. In the end, these two negatives are going to cancel and become a positive. Because you're not going to have negative answers in these. We're not dealing with negatives. We're dealing with positives in all of our word problems. Divide both sides by 43. I'm going to go ahead and just not put that step so I don't run out of room. And v equals a positive 5. Now, if you notice, this original equation is really easy to figure out. If we had 8 drivers, then we plug in 5 for vans, and we know we have 3 buses. You could take 5 and plug it in here and find the buses, but it's going to be a lot more difficult than that equation. And you would write your answer. There should be 5 vans and 3 buses. Or something like that, where you're labeling it and you're writing it in words.